Approaches to prevent session hijacking. Uh, so use HTTP strict transport security (HSTS). So HSTS is a web security policy that protects HTTPS website against MITM attacks. Uh, Strict transport security is the key here. So the HSTS policy helps web servers force web browsers to interact with them using HTTPS. Next is token binding. When a user logs into a web application, a cookie with a session ID called a token is generated. The user utilizes this random token to send requests to the server and access resources. So token is nothing but a cookie with a session ID. From this session, it's from this sentence, it seems like that the session is the token is nothing but a cookie with a session ID. The client creates a public private key pair for every connection to a remote server. When a client connects to a server, it generates a signature using a private key and sends this signature along with its public key to the server. So private key will be with the client. It will generate a signature using the private key and it will send the public key to the server. The server verifies the signature using the client's public key. This ensures that the message was sent by an authentic client because only the client has its private key. Even if an attacker is able to capture the signature, it is not possible for them to regenerate the signature or reuse it for another connection. For every new connection, a new pair of public and private keys are used. HTTP public key pinning. So as you can see here, the implementation of HPKP, HTTP public key pinning. HTTP public key pinning here, as in the shown in the figure, the server first sends a public key using HPKP and then it establishes a TLS session. So verify server's public key. The client verifies the server's public key. If valid, then the connection will progress. If it is invalid, the connection will be broken. So approaches to prevent MITM attacks: WEP, WPA encryption, VPN, two-factor authentication. So the Internet Protocol security, IPsec, is discussed in detail um, in the book provided by EC Council, Aspen book. So better to refer that. In this, I'm trying to summarize what is given in that. So IPsec is it's a set of protocol. It's not a single protocol. It's a set of protocol developed by Internet Engineering Task Force. It supports network layer peer authentication, data origin authentication, data integrity, data confidentiality, and replay protection. It is widely used to implement VPNs and for remote user access through dial-up connection to private networks. So it supports transport and tunnel encryption modes, although sending and receiving devices must share a public key. The security services offered by IPsec include the following: rejection of replayed attack. You saw there was one attack called as a replay attack, where where the attacker uses the vulnerability of sending the same session ID again to the server. So this is called as a replayed attack. So if you use IPsec, the replay attack can be avoided. Confidentiality, data confidentiality used by encryption, access control, connectionless integrity, data origin authentication, data integrity by using hash, limited traffic flow confidentiality, network level peer authentication, replay protection. Mode of IPsec: tunnel and transport mode. In transport mode, also ESP, IPsec encrypts only the payload of the IP packet, leaving the header untouched. It authenticates two connected computers and provides the option of encrypting data transfer. As you can see in the figure, IPsec header is added after IP header. So IPsec trailer ESP only. In tunnel mode also AH, the IPsec encrypts both the payload and the header. So in the transport mode, only the payload was encrypted. Here, both the payload and the header are encrypted. Hence, in the tunnel mode, has higher security than the transport mode. The tunnel mode is used to create VPNs over the internet for network-to-network communication. Example between routers and link sites. Host-to-network communication. Example remote host users access and host-to-host communication. It is compatible with NAT and supports NAT traversal. In tunnel mode, the system encrypts entire IP packet, payload and IP header, and encapsulate the encrypted packet into a new IP packet with the new header. In this mode, ESP encrypts and optionally authenticates the entire inner IP packets, whereas AH authenticates entire inner IP packet and selected IP fields of the outer IP headers. The tunnel mode is usually useful between two gateways or between host and a gateway.